That yesterday this transmission, the stream is not very good. 4G is having
very light.
cannot do. So today I'm just going to run through again. Start with this model. I think you want to explain this one.
Okay. So this one is continue with our last week session. So last week we demo the
meter.
Yeah, the watt meter one. So and then I promise we will continue on the pressure one. So okay, now let me switch the screen.
Because right now two systems is sharing one monitor, so Kenyong is doing the switching to the other side. So of course, this AI model is run on a very tiny processor, only 2 core in one to do this analog meter reading.
Okay. So now same AI software can run in another platform. So this one is the ICO 100. So you can see the result over here. So allow for 0.6, yeah, 0.61. So all this information, the value that it digitized, can be sent to our cloud. And then at our cloud side, you can configure the threshold value. So when it exceeds certain threshold or below certain value, it can trigger the alert. So you can alert through the email, WhatsApp, Telegram, and actually there's one more, the SMS. Yeah. And then for this AI, it doesn't require a sharp vision. So let me show you why it doesn't require a sharp vision. So okay, let's say I make this one blur a bit. So now the value is 28 something. So even the become blur, sometimes cannot do blur. So it's like this. So the value only sometimes increase by 1 only. So of course, a sharp vision will give you the most accurate result.
Are we live now? Are we live now? Okay. Hey, jom, let's Sembang AIoT. So just down the screen, just now you're watching it was recorded yesterday. We want to bring, first of all, welcome you again watching our live today. A very good afternoon, good morning or good evening, wherever you are. So me and Kenyong here, same thing we are sharing with you. Just now when you were watching, because we were in the Smart Nation Expo yesterday, So Kenyong also worked like a reporter, we do a live stream yesterday. No, the day before, is it? Or yesterday?
Yesterday.
Yeah, we did it yesterday. And then the video was so so lag, so lagging. So because of the 4G, actually, we're supposed to subscribe to 5G. But anyway, part of it also because of the resolution. Yeah, the resolution, it was set to quite high resolution. That's why it's not able to stream over. But anyway, we learned from the live session from the Smart Nation Expo yesterday. Okay, just now you see, as promised, I think that session was recorded, and then we talked about the vision AI, vision AI based on the analog reading. Yeah. So maybe Ken Yong, you want to describe a little bit from the previous video just now when we was doing.
Okay, so the previous video is to talk about, I think last week we talked about we use the camera looking on the voltmeter. So the voltmeter shape is a square one. And then last week we didn't show how the AI work on the pressure meter, because the pressure meter usually come in a circle. So some people might think that, so if your AI can work in the square shape meter, does it also able to work on another shape of the meter?
Yeah.
In fact, all the researchers, they start working on this, they are start with the pressure meter first, because the pressure meter is widely used in the industry to measure the pressure. So, and then they usually use the OpenCV, the circle detection algorithm, to perform this kind of task. Okay, usually the circle detection is to locate where is the meter. After that, then they will use the light detection to detect the scale in the pressure meter. So if you run the AI or the machine learning algorithm without the circle detection, then all the surrounding object that come with a straight line, it will be detected. So they use the circle detection to find out, to identify where is the location of the meter first. Then all the straight line thing outside the meter will be ignored. So when this thing want to apply into another shape of the meter, for example, the square one or the rectangle one, then the circuit detection algorithm, it might fail. So we decide to use a new approach where we use the deep learning algorithm to identify where are the scale and also the pointer. So the deep learning is more powerful than the OpenCV a lot, but it also comes in a cost that it would require more CPU power to run it. But at the end, what the industry wants is the accuracy. So they are more care about the accuracy. So because if your product, if the AI can run very fast, but the accuracy is not good, it's not there, no one is going to use it. Because it just gives you all the wrong reading.
Okay. So today is also very special. We also broadcast this one live to the Telegram. Hello, some of the Telegram follower or some of our customers who subscribe to our Telegram. So for some of you who miss to claim some of your gift at our booth yesterday, please let us know. We know we have many new friends come on board onto our YouTube channel since yesterday. Some of them are even from Sri Lanka. We have a subscriber from Sri Lanka, one of the Sri Lankan friend, subscribe to this channel. And then we have someone from this from Negeri Sembilan, from Negeri Sembilan, Nilai. Some of the factories friends, who love our demonstration yesterday. It was a tiring 3 days. It was a tiring 3 days in the exhibition. Always go back, not enough sleep, because there are many works to do after that. If you like this channel, please SSL, share, subscribe, and like us. So we thank you for all your support. So today's sharing is just to describe. I was telling Ken Yong, after the shows, we see many new things. There are people from. Of course, we are attached more to the Taiwan side, Taiwan team. The whole team. I think some of them are doing semiconductors and even radar sensors, those things. If I have time, I will share with you a little bit about this when you're doing the IoT measurement on the level, you use ultrasonic sensors. What about how different from it to these radar sensors? And also, what is the main difference between this radar and the ultrasonic plus the lidar? What are the differences? Of course, these are the sensors are very relevant in measurement, especially in the IoT. Next time will be port over to AI, how you can do machine learning and so on. This area, but today mainly I think we start off with. We want to try to we want to describe. These are the three main key products that we were showcasing in the Taiwan slot, in the Taiwan pavilion, yesterday, the last 3 days. The first one is the network appliances. Yeah. So talking about IoT, you cannot run away from network security, cyber security. These are the industrial grade cyber security box as appliances that some of our clients already built in their own software, and also some of them are still evaluating on certain areas, especially in the manufacturing, even in some of the oil and gas and so on. Yeah, so you can put in your own software, and then in terms of IO, this guy, we have a 2 series. This is 110. We have another 200, 4 LAN port, and also 1 console port. For those of you who are in the cybersecurity, console port is very important. Just like what you did with this Cisco router and Cisco this Jupiter, another brand of this cybersecurity box. You need the console to do configuration and so on. Yeah. And then good thing about this one is when you do some open source cybersecurity software, for example, PFSense, OPNsense, we have this video output, if for you, it's very easier. It's easier to configure. Of course, some of you use this one for SD-WAN, purpose. Yeah. And then you want to describe about this one?
Yeah, before I start, I think we could add one more for this one. There's a built-in TPM inside.
Oh, okay.
Yeah, so which is very important for the cybersecurity. So what the TPM do is when you put up your Windows, the TPM will guarantee that you are putting right to the original Windows, the Windows kernel, not the one that already been modified by the hacker.
Oh, okay. Yeah, that's a trusted platform module. Something. Yeah. That's yeah. Continue again.
Okay. So for the second one, this one is the ICO 300. So this one is a new model. So it adds in some more port, and also this one is the IO, right, over here.
Okay. There are some serial port interface, isolated serial port, where usually RS-232 or 485 you don't bother is whether isolation or no isolation. But in most of the application, especially outdoor application, isolation is still a mandatory or a must because of this kind of interference from the external environment.
Yeah. If I remember correctly, this one support it has the anti-explosion certified.
This is with the ATEX Class 1 Division 2 ATEX certified. So it can be used in some of the oil and gas, a certain zone, a Class 1 Division 2 zone. Yeah, this is C1D2.
Okay.
So the last one also in the Taiwan booth, is it? We set it up there. Yeah.
The last one is the ICO 520.
Yeah.
So this one is a totally new model. So it supports a 12th gen Intel processor.
Yeah. Okay. So if you remember, if you follow our channel before, we have this ICO 500 series. Yeah, this is the latest model that already streamed down to a very compact platform, form factor that you can develop your own application here. Of course, our SCADA platform, embedded platform like Tesla, or Aviva Edge, or Indusoft, or even the new Adistra, that kind of software, you are able to put it inside to get it run. One more thing is most of our device actually come with a general purpose point where you can design your own LED lighting. It's a general purpose I/O that you can use our API. All of these devices we give you an embedded API that allow you to integrate to your program. For example, you write C#, you write Linux software, Python, and so on. You are able to freely use the library to tap onto even the CPU status, health of the system. Those things are available, included just now I said the I/O. Yeah, you can integrate to that. Okay, that was one chapter, when we talk about this one. So I just want to share with you some of the things that I've seen, since the last 3 days. Of course, there are quite a number of foreigner exhibitors, China, Russia, Korea, Singapore, yeah. So of course, Malaysia. We are on the Taiwan side, but we have another booth. Just now you saw the channel, just the earlier video that was at our own booth. And one thing is I just want to share. Just now I'm talking about there's one of our Taiwan partners who showcased their radar kind of sensors, radar. So just to cover that as one of the industrial IoT channel, in terms of measurement, yeah. So in the next coming video, we are going to, or live session, we are going to talk more about IoT sensors. Yeah, I think in the past 5 or 6, we have covered enough smart manufacturing, as a general concept of OEE, predictive maintenance, process automation, and so on. Yeah. So this coming, we are going to coming live. We are going to talk more about sensors. To start off with, I would like to share with you one part of it is a radar sensor. Usually, yeah, in most of the project in terms of measurement in what they call the level, water level or any liquid level, it can be petrol, it can be petrochemical, can be oil, can be water. Yeah. Usually you use ultrasonic, because I think ultrasonic maybe is a slightly cheaper solution. And then there are options like radar. There are people using, but quite rare. But they have a certain requirement why you need to use radar to do measurement. Okay, on the radar. And then also, of course, LiDAR. LiDAR is not so much on the measurement, but more onto the navigation thing, like used in autonomous mobile robot. Yeah, I just want to tell you the two differences between the differences between the ultrasonic and the radar. Of course, by the name, ultrasound is using a sound wave. Sound wave. So when you're using sound wave, you're bound to have some problem in terms of temperature. Let's say you are measuring a tank inside, the vapor is going up to maybe almost 100 degrees Celsius. That is the part where you have problem getting the accurate reading. Yeah, that is one thing, because the temperatures go up. Because sound, you need to use the media, the air to transmit. Yeah, so it gives interference. This is one part. The second part is if you have a very dusty, smoky or dusty environment, so that also it will affect the reflections of the sound wave. Yeah, because basically ultrasound levels measurement is based on what it transmits and then how it bounce back, and then you get the time of transmission. All those things you can measure what is the distance. Yeah, this is how this thing is being measured. So of course, on the radar side, it is also, because radar side is you are using EM wave, basically electromagnetic wave. So when if talking about radar, I think if you go on the highway last time, all your summon actually coming from the radar sensor where police put a radar sensor to do the speed trap. Last time they are using a radar, but right now people have been using laser and so on. More very accurate. So radar is it depends on the dielectric strength. If you know the physics side, dielectric strength. If you have a media that is not conductive, then you have problem. Radar is not able to do so well. Yeah, and also it is less affected by those environment. Especially on the EM side, compared to the sound. These are some of the advantage on the using the radar. Of course, our radar still a more expensive way. But just I want to share, in terms of IoT, in terms of AI next time, I think there is a possibility of using radar, to do some, of course, measurement and also tabulating the data on the surface, because it can tabulate a 3D profile. Yeah. So this 3D profile later on, if let's say those data can be fed into the machine learning, those you are able to do AI onto this set of data. Yeah, I can't think of any application yet, but I think there will be a good application. Right now, I think radar is used for anti-collision. Anti-collision. Some in the I've seen the video played by the vendor who provide this one. They are using that for those people who do the maintenance on the airplane. So the movement of the vehicle that move the people to do some cleaning or checking. Those things are protected by the radar sensor. So it'll be doing automatic braking. I don't know whether the new car is using the radar. Maybe not. Maybe using a LiDAR. LiDAR is more for the auto moving vehicle. That is the sharing that I want to share about this IoT. In terms of, because I saw the radar sensors and ultrasonic right now. They give you a Modbus interface. It can be Modbus RTO or Modbus TCP. As you can see, some of our devices, gateway, or even our 4G router is able to give you all this data, capturing this one, and then you can publish that to the cloud. So that will be my sharing today. But maybe we want to bring up some of the thing that you may miss out in the exhibition. Maybe before that, can we share the screen? Can we share the screen? You share the picture, one of our picture. Okay, just want to share. Okay, that was our team. Exam Tech Malaysia is showing in our show. Your best AIoT partner, at the back of a Canon, this lettering is your best AIoT partner is covered. And then in front of that is one of the conveyor belt. Maybe Canon, you want to explain that part? That one is on the supervised AI learning that we have shown in some of our past video before, but we set up this one properly. We demo in the exhibition. Maybe Canon, you want to touch that part.
Okay. So this one is our very first AI software, the AIS. So we're using the supervised deep learning. So what we demo over here is we use the AI to detect the steering sticker on the tripling part. So we have two tripling part that is without the sticker and one is with the sticker. So you can see that there's a camera above the tripling part. And beside it, there's a e-box, our instruction PC. So the AI is running inside here. And then for this time, we set the conveyor belt moving at its faster speed.
Yeah, it's about zero. I think lah, agak lah, 0.5 meter per second lah. 0.5 about 500 cm. Is it 500 cm? No, 500 cm. 50 cm per meter lah. 50 cm per second. 50 meter per second. 50 centimeter per second. Yeah, 50 cm per second. Yeah.
So compared to last year, when we showcase this demo, we are running the conveyor belt at the slower speeds.
Yeah. So some of you is asking about some. I met some of the trainer, some professor trainer, and some of the, of course, some factory people. And then we have one case. They asked whether you can use that to count the fish that are producing, not producing that they're receiving some fish or eel. Yeah. So they want to count the thing. The answer is yes, lah, of course. But we have to get those data. We can prove that to you. If some of the system integrator partner outside that who know us, you can also bring some of the cases. You are always welcome to bring some cases for us to do study together with you. We can collaborate with you in some of your project. Yeah, that's one part. And what I want to say is here, yeah, we do a very clear differentiation between the supervised AI learning and also the unsupervised. The unsupervised is at the other corner, but I don't know whether we have a picture here. We may not have. But one more thing I want to touch is, can you show the diagram again? Because we are using our e-box. Yeah, we are using the ExomTech e-box. Some of them is asking where is your GPU? Where is your GPU sitting? Yeah, he's asking where is your GPU sitting. Basically, the whole AI is done on the OpenVINO platform. So we are able to leverage some of the OpenVINO code that it has already been optimized to run on the Intel processor. That's why you do not need to use GPU. For some cases, I think for most of the cases, especially you go up to the higher generation, you can tap onto that. That's why some customers say, is it you are doing cheating? So of course, go to exhibition cannot do cheating nowadays. Maybe 20 years ago still can. But now people can see things, they want to touch, and then you can search online and then double check on you. So that was the one of our demo. Yeah, one part I want to touch is, of course, talking about the whole software. This software AIS was co-developed together with Intel in the past by a ExomTech Taiwan team, and then it's being further improvised by our team with Kenyong. We have done this one very easy to do, collect data set. In fact, the whole thing is end-to-end without very low coding low code. Practically, you don't need to do any coding. And then plus, we have already integrated one of the SCADA engine inside. You can link some of the AI data to the SCADA platform. That when you come to SCADA, you can put up those very wonderful symbol object, even animation, plus your AI data. That will be very wonderful. That can make up a good solution for your customers. So that part, I will just want to end that part. So can we move on? Maybe we move on to the other side. Okay. Today is a recap and a full summary of what we have done. You can see this one. For those of you who do not have time to visit our booth, yeah. So this one is presented based on the predictive maintenance, a small model of predictive maintenance. Of course, we have vibration sensor. Yeah, vibration sensor. We have vibration sensors. So in this case, we showcase the vibration sensor come with a 3 axis, running a Modbus RTU. Okay, then the fan, when the fan is moving, it's generating the vibration. And then the bottom one is the, maybe.
Yeah, this one is the power meter.
Yeah, power meter. And then we would like to thank IT Micro for sponsoring this power meter to us. Yeah, so this is quite a good features, within the IT Micro power meters. This one is being connected to one of our IoT 4G gateway. Yeah, so of course we can use this one. Previously we were using our ExomTech IoT, but we just want to make it more minimized. This is just pure transmission. Yeah, pure transmission. So you can use one of these 4G. After configuring, you can practically publish data to the cloud. So as far as our cloud, this platform is concerned, I think currently it's called AIoT Edge Connect. So it's able to accept, it's able to accept all these on a JSON format, REST API, and also MQTT. Yeah, this is how we do. And then we also have partners who use some of this product to publish. We are on this part, we are open. You can use any other cloud. You can publish to your own cloud as well. Yeah. So for that thing, maybe you can explain to the audience. What are the thing after you collecting the data? What can we do up there?
Okay, so for example, in this case, we are collecting the vibration from the vibration sensor. So actually, the vibration sensor provides us the amplitude, velocity, the acceleration, and also the frequency. Yeah, there are 4 parameters. And then, of course, it's not that simple. This one can produce more parameters. So I just simplify them into 4 categories. So once this data being collected by this IoT gateway is sent to our cloud. So in our cloud, we have a database. And then we also run a very simple machine learning algorithm to do the anomaly detection. So it will retrieve the data from our cloud database and then perform the anomaly detection. So, and then when there is anomaly occur, our cloud can send the alert through the either email, WhatsApp, Telegram, and SMS also.
Okay.
And all this cloud you can view on your mobile phone or your tablet. Yeah.
Okay. If you have any question, you can also put your comment in your Telegram or in any Facebook or even YouTube. Please give us a comment. And again, you are watching the Jom Let's Sembang AIoT. Me and Ken Leong doing a sharing for you this afternoon. And yeah, this is one of the part that we are doing some AI machine learning, a very simple model. Of course, predictive maintenance can be quite sophisticated. You want to go into the deep level. That one, for this demo, we just do a more simplified machine learning model. Okay, maybe we just bring it up, and then we will go to another one. Okay. Yeah. So we are something like showing the toys. So for this part, in the exhibition also we do a demo on this OEE tracking. How can you use our system to do OEE tracking? OEE tracking for this one is quite simplified. We make it a very simplified model where you can make use of this product like a stack light module. This one from ICP. So we are integrating to our ExomTech Edge HMI, or we have 2 versions, Edge HMI. This is with head, without head one, we call it headless, it's become our IoT Edge gateway. Yeah, so that is one part. And then we are using the simulation, what are the simulation we have, Agena?
Okay, so we have this one is our simulator. So it's something that will keep on rotate, and then there's a sensor over here. So when it rotates, passing through this region, the sensor will detect something passing through. This one is to simulate there's a product being produced. So this one, it will send the signal to the stack light tracker through the IS485. At the same time, you also have the tower light simulator. So usually, when your machine is running, the tower light will show the green light. So when something wrong with your machine, it will turn on the red light. And there are 81 combination to representing the status of the machine.
Why 81 combination?
Why 81? So beside,
maybe before that, we just ask the audience why, three digit or 3 bits, how can you give a 81 combination? It's not possible, right? It's not possible to give you a 81 combination. Yeah. So
okay. Usually the light only on and off, right?
Yeah.
But in order to achieve 81 combination, the light need to blink.
Each of the states can be blinking, a combination of different blinking, it make up to be more combination.
Some on and then another.
So usually you
blink.
have 8 only, right? 2 power 3 is 8 only, right? Yeah. So with blinking, so in terms of blinking also, actually in most of the machine you need to track some of the blinking status also. Yeah. So for that part, the module will be able to calculate for you, quantify for you what is the interval that event has gone through. So that is very important, because by using that, you are able to, quantify this set of error, is due to what, based on the status light. Yeah. So that is very important. In fact, all this thing. But at the same time, also by doing the counting, also the module is able to give you the cycle time. Yeah, because OEE, basically you want to do OEE, you have 3 main things. What are they now?
Availability, productivity, and the quality.
The quality. So in this case, the availability and performance is already tracked. Yeah. So the only thing about quality, where does this quality come from? Yeah, this actually come from our HMI. Of course, we have some of our visitors who came in. They also do OEE. Yeah. So they want to use, can AI contribute to this thing? That one is last year we keep on promoting, but seems like no response. But today we received back the same different set of visitors asking for that. Yeah. So sometimes we do a little bit advanced, maybe we have to slow down a little bit. So we talk too far away. Okay. So for that, actually, you can see all the OEE, and then you can enter some of the defect, for some manual, or you can link to our AI. You can link our AI, so that will be a complete OEE, system. Of course, from there on, same thing, you can publish to the cloud. And then just want to highlight one of our cloud historian, where you can also, we have this capability for you to open to any, if your ERP software, or if your MES software, or any SCADA software would like to subscribe back on the data, you are able to do that.
Yeah, we provide the API for you to do that.
Yeah. But for this implementation, it can be on a hybrid mode. You can do on the local SCADA. That interface is ready. It's ready. So you want to find out more about this one, you can contact with us. Yeah. So last thing to describe about this one, Agna?
Yeah, I think you cover everything there already.
Yeah. Of course, some production process, you say, hey, I have 6 light, can I do? Or 4 light, can I do? This module is able to handle up to 6. Yeah. So you're definitely able to do it with this single module. So we have made this one simplified for you. Implementing this one is not a problem. Further from there, we are able to give you a training on how you can implement those things. Okay, we are on the last already,
Okay.
So again, before we end, we would like to tell you this is a Jom Sembang AIoT channel. Very sorry because the other day when we were in the exhibition, we tried to do a live. In fact, we want to go to each of the booths, some of the booths that not belong to us, we want to do some capture, but the line there is not very good on the 4G. Yeah, it's time to go for 5G, because IoT basically you hardly use 5G, but some of these broadcasting, you need a 5G. So yeah. So any last thing that you want to share? Is there any last thing?
Think no.
No. So if no, we just want to say thank you very much for watching, and we always innovate.
Innovate, we
We
train.
innovate, of course, we apply, and then we share and we train. Yeah. So thank you very much for watching, and then we'll see you in the next session. Bye-bye.
Bye-bye.